This is linear algebra. We want to talk about metric operation. We did sum and scalar multiplication. Previous video, we are focused on metric multiplication. Guys, make sure this is not scalar multiplication. This is metric multiplication, guys. Start how we're gonna do metric multiplication. First, you have very carefully understand, guys, when you do the metric multiplication is you have A metric times B metric. So go to the size of A. Size of A gonna be M times N. M rows, N column. Size of B is N times P. So we want to define A times B. Metric multiplication. Make sure, guys, here is very important concept here, guys. Make sure this number of column of A, number of row of metric B should be same. Otherwise, we cannot define metric multiplication. Guys, make sure it. Then how can define the metric multiplication? You have this one is gonna be B gonna be N times P. How many column vector is P? So you rewrite metric B in terms of column vector. Then we're gonna define multiply A, B gonna be this way. Metric A times B1, metric A, B2, metric A and BP. This one gonna be new metric. After multiplication, you have size M times P, guys, okay? That's you're gonna do. Here is M, here is N. That's the definition of metric multiplication, guys, okay? Let's practice it. Do it, guys. Let's say we're gonna do A and B right there, guys. So first, you're gonna write, let's check the size of A, gonna be 2 times 2. Size of B gonna be right here. How many? Row 2 times 3. So check it. This one. Number of column, number of row is the same. So we're gonna define A, B metric multiplication. So this one is size gonna be, guys, size gonna be 2 times 3. So 2 times 3. That's we're gonna find a new metric. So now, when you see this one, guys, this definition is AB1, AB2, AB3. Remember the column vector? Here. So this one is B1. This is B2, this is B3. So this gonna be B1, B2, B3. Okay, let's figure it out, guys. So AB1, guys, what is A matrix? 2 and 3, 1, negative 5. That's gonna be B1, 4 and 1. How can define to this metric, guys? Remember that, everyone? Everyone remember? This one gonna be 2 times 4 plus 3 times 1. Second row, 1 times 4 plus negative 5 times 1. So you have new metric gonna be 8, 3, 11, 4, minus 5, negative 1. Let's do one more. A, B, 2. What is a metric? A metric is 2, 3, 1, negative 5, 3, guys. B2 metric, B2 column vector gonna be, column vector gonna be 3 and negative 2. This one is 2, 3 plus 3 times negative 2. And 1 times 3 plus negative 5, negative 2. So what do you see? 6 minus 6, this is gonna be 0. Here, 3 plus 10, that's gonna be 13. Guys, make sense? The last one, AB3. You can stop the video and then do by yourself, guys. column vector B3 gonna be 6 and 3. You have this one, 12 plus 18, right? 12 plus 9. I'm sorry, guys. 9 and 8. Oh no, 6 minus 15. So you have 21 minus 9. Okay, you find all the column vectors, right? So you have A and B. First column is going to be 11, negative 1. Second column, 0 and 13. Third column is 21, negative 9. Can you see that? What is the size of this matrix? 2 row, 3 column. That you find it, guys, okay? All right. Take a while to find multiplication of two vectors, right? So I'm going to introduce row column rules, guys. How can find entry of multiplication of two matrices, okay? So AB, multiplication of two matrices, we want to find the IJ entry of AB. So that case, you're going to see this is, guys, make sure this is A matrix. You're going to pick I gonna be, you're going to pick row I of matrix A. Here is J gonna be J vector of matrix B. So that's times each entries, guys. So how can find the entry ij of matrix A and B? Guys, look at this. AI1, Bij, B1J, I'm sorry. AI1, B1J. Guys, here is you pay attention. This number should be same. Okay? AI2, B2J. All the way AIN, B and J. Okay, that's how to find entry of AB matrix, guys. Okay, you're gonna using this rule to find multiplication of two matrix, guys. Okay, let's do this one by using row column rules, guys. They say what? First row, guys, look at that very carefully. First row and third column. First row coming from the A matrix. Third column gonna be B matrix. So how can find this one? So we're gonna see, guys, here. 2, 3, 1, negative 5, 4, 3, 6, 1, negative 2, 3. So we want to find the outcome of this multiplication. First row is right there. Here is the third column. So first row, third column. That's what we are looking for, right, everyone? Make sense? How can find this one? So how can find it? First row of A. So that's gonna be this one. This one coming to the third. That's coming through this one. It's the first row. Here is the third column. So we are looking for, guys, actually, we are not worrying about anything else. We only need this part. So let's find this one. 2 times 6 plus 3 times 3. That's going to be 12 plus 9. That's going to be 21. That should find this one, okay? We are not looking for anything else. Everything makes sense? We already talked about size of AB matrix, guys, because here, size of A is 2 times 2, size of B is 2 times 3. This one, outcome of the multiplication of two matrix is going to be 2 times 3. So we already know. Okay, let's go to this one. As we did, guys, you just pause the video, try to figure it out. So let's go this one. So we are looking for, guys, 2, 3, 1, negative 5, 4, 3, 6, 1, negative 2, 3. So we already know the outcome, guys. 2 by 3 matrix. So here is a 2 by 3 matrix. So what are you looking for? 2, second row, second column. So we are looking for this one, okay? How can find this one? So 2 coming from here, guys. 2 coming from this A matrix. 2 second row, row 2. This is, guys, coming from column 2. So we're gonna talking about this row, this column. So how can find this one? So I'm gonna erase this. Let's find it. This 1, guys, 1 times 3. That's gonna be 3. Negative 5 times negative 2, that's the 10. So this number is 13. That's how you find each entry of multiplication of two metric, guys. So row column rule is more popular one. From now on, guys, you keep practicing how to get the multiplication of a two matrix. Let's go to practice, guys. Pause the video. You just try it by yourself, guys, okay? First one is we're gonna use definition. Definition meaning is we're gonna use column vector of B. Second method is we're gonna use row column rules, guys. Okay, before we start multiplication of two matrix, let's just start with the size of two matrix, and then we can find the multiplication of two matrix or not. Okay, let's check it, guys. Size of matrix first. This one is 3 times 2, 3 row 2 column. This one is 2 times 2. So 2 row 2 column. Oh, see that? This number is the same. So we're gonna have AB matrix. Size gonna be 3, 2. So 3 times 2 matrix you're gonna looking for, guys, okay? So let's do, we're gonna do based on the definition. So that case, guys, you have to rewrite this is column vector. So this one is B1, this is B2. So this one is B1, B2. Then we're gonna define the AB gonna be, how can define the multiplication of matrix AB1, AB2. So you can do the AB1. That's gonna be, guys, AB1 is negative 1, 7, 3, negative 2, 0, 3. We're gonna times the column vector. Here is 1, 3. Okay, so you have negative 1, 1. That's gonna be negative 1. 7 times 3, 21. Second one, 3 minus 6. Third one, 0 plus 9. So you have AB column vector 20, negative 3, 9. Everybody make sense this one? You did the same thing, right? Okay, let's go AB2. AB2 is exactly the same. You're gonna do negative 1, 7, 3, negative 2, 0, 3. B2 vector is gonna be negative 2, negative 3. So you have this one gonna be 2 minus 21, negative 6, positive 6, 0, negative 9. So you have negative 19, 0, negative 9. So what is the answer of AB vector, right? So you have this one. First column vector gonna be 20, negative 3, 9. Second column gonna be negative 19, 0, negative 9. So you find the multiplication of two matrix. Okay, this time we're gonna using row column rules. So let's go to here. So A matrix, negative 1, 7, 3, negative 2, 0, 3. Here is 1, negative 2, 3, negative 3. Okay, let's do it, guys. Here it is. Very carefully listen, okay? We are looking for a first row, first column. That's it. First row, first column, right? That's how I'm going to write it. That meaning is first row, first column. So you have negative 1 plus 21. Everybody make sense? Here is first row, second column. First row, second column. That's going to be negative, positive 2, negative 21. Everybody make sense? Let's go here. Here is going to be second row, first column. I'm going to here is make a small, guys. Which meaning is you have to do here second row, first column. So 3 minus 6. Right? Here is second row, second column. You need negative 6, positive 6. Okay? Another one, last one here. Here is 3, third row, first column. That's gonna be third row, first column. 0 plus 9. Here is third row, second column. That's gonna be 0 minus 9. That you find it, guys. Everything makes sense? So you have simplify all the number is 20, negative 19, negative 3, 0, 9, negative 9. Exactly same answer, guys. That's how to do the multiply to matrix, guys. Okay. All right. Let's go over property of product multiplication, guys. So first one is they talking about this one is you're gonna be when you do the multiply 3 vectors, order doesn't matter. This association rule A times BC, BC first and times A, or AB times and C later is the same, okay? This one is a distribution. You're gonna metric. Here's addition of a metric. You're gonna times B. So you're gonna do time first and addition later. It's the same thing. Scalar multiplication, you multiplication of metric first and time the scalar number, or here scalar multiplication and do the metric multiplication later. It doesn't matter. So identity metric times metric, always metric itself. It's like times 1 times 2, always 2. That's the property of multiplication, guys. But here is very, very careful with commutative, okay? So this one is, you guys, when you do multiplication of a 2 metric, you cannot mess up with order. A times B, B times A can be same in the multiplication of metric. Number is order doesn't matter, but metric you have to very, very careful. So I'm gonna give about this one, guys, okay? Before we do the multiplication of two matrices, let's check the size. This is 2 by 2. This one is, guys, 2 by 2. This is 2 by 2. So AB matrix size is going to be 2 by 2 because here same 2 by 2. BA matrix going to be 2 by 2. So size is the same. Doesn't mean metric is the same, okay? So which method do you want to use? It's up to you, okay, guys? But I'm going to use row column rules, guys. Let's do this one first. So this guy first, I'm going to do it, guys. Here, I need a space. Let's move this guy. So here is AB 5, 1, 3, negative 2 times 2, 0, 4, 3. So guys, I'm going to write down for you. Row column rule is, here is, you're going to do first row, first column, first row, second column, second row, first column, second row, second column. So first row, first column is you're going to using this one and this, okay? So I'm going to do it 10 plus 4 is 14. Guys, make sense? Okay. First row, second column. First row, second column, right there, guys. Okay, 5 times 0 is 0, 1 times 3 is 3. Oh, I should use this one, guys. This one, second row, first column. So I have, what number I have, guys, okay? One number, 3 times 2, 6, negative 8, negative 2. All right? Last one, second row, second column. So negative 3, negative 2, 0, 3. So this one is negative 6. Everyone got the same thing? Let's go to BA this time, guys. Let's do the BA. BA, also 2 by 2, BA. So B first, 2, 0, 4, 3, 5, 3, 1, negative 2. So we have this one. Pause the video, you can do by yourself, guys, okay? I'm gonna do here 10 here. Here is gonna be 2 here. 29 here, guys. Negative 2. Can you see that? BA, AB, same or different. Can you see that this one? Very important, guys. AB is not same B of A. So you cannot mess up the order of multiplication of two metric, guys.